So, my name is Ranjeet Ranjan Jha, and I'm here uh, at IIT Patna. I'm assistant professor in mathematics department, and I generally teach all those deep learning based advanced topics like deep learning, then large language models. So these are like my areas of teaching. And apart from that, like my background is computer science, so I also teach some of the computer science subjects. Okay, so with that, let's begin. And this lecture is like uh, this is about overview lecture. So we'll just touch every aspect of the deep learning, but in a brief manner. Okay, later like we'll dive into the deep learning. Okay, so let us start with like from where this evolved, from where it started. So initially, like this whole thing, whatever we are seeing nowadays, everything is derived from the artificial intelligence. Now, artificial intelligence is very big area. So let us go to maybe early like 1960s or 1970s. That time, uh, like people used to use this computer system for solving multiple type of problems. And then what we were doing, we were just making the algorithm, and then our computer solve those problems. Okay, so at that point, there there was the smartness from our side because we were using our mind to develop the algorithm. Okay, so that was like traditional, or we can say the previous era. But when this AI came, and then AI gave the idea that why not this smartness should be given to the computer only. So can computer itself decide how to write the algorithm for solving particular problem? Okay, so we are making the computer smart, or we are making the computer system intelligent, and that's the starting point of artificial intelligence. Okay, so artificial intelligence is very big area. A lot of things are there inside the artificial intelligence, but job is to make the computer system intelligent, just like human. Okay, now inside the artificial intelligence, we have a lot of different type of things involved there. One is computer vision, which is uh, the goal of this computer vision is it's like mimic the human vision. So how we see, how our brain interpret. So in the similar way, can we mimic all those type of things through this computer system? Okay. So like when we just see the human vision, then what we do, we have camera, like we have eyes, and eyes can be considered as a camera. And eyes are taking the image of every object, and then our brain is interpreting the image, whatever have been taken by the eyes. Okay, so brain with combination of eyes making this human vision. Now computer vision also came for the same purpose, and computer vision is having camera, the actual cameras, and it is having a lot of algorithms for solving different type of problems. So what will happen, cameras will take the images, and then it will apply the algorithms to interpret something from the images. So that is one area which is called computer vision. And then we have machine learning. Now this machine learning, this machine learning, this came up with the idea that we can somehow train the machine. So it is giving a lot of techniques for training the machine. Okay, and that's why this is called machine learning. That it means like your machine is learning. Okay. And then inside this machine learning, there is deep learning. And our topic is deep learning. So we are going to study this deep learning. So deep learning is the area, or deep learning is the topic in which we are interested. Now, if you just see here, this deep learning is also part of machine learning. It's like the big circle is for the artificial intelligence. Inside the artificial intelligence, we have computer vision, and then we have machine learning. Again, I forgot to tell, I machine some of the machine learning techniques have been used or are being used for solving some of the computer vision problems. So nowadays, again, for most of the computer vision problem, people use machine learning or deep learning type of techniques. Okay. So that's why there's overlapping between machine learning and computer vision. Now there's deep learning. And deep learning it can be seen as a subset of machine learning. It's part of the machine learning. Okay. But there is difference. Machine learning, whenever I'm saying machine learning, that means it is talking about the traditional machine learning. And whenever I'm saying deep learning, that means it is talking about the new machine learning. Okay. So these two things are part of the machine learning only, but one is new type of techniques, and another one is at this part we have traditional machine learning. So first we'll see the difference between machine learning and deep learning. What is I should not say machine learning. I should say traditional machine learning and deep learning. So let us see this difference with example. So we have this is the part of the machine learning, and this is the deep learning. Now, this machine learning, whenever I say machine learning, this was like you might have used some support vector machine, some KNN based technique, different type of machine learning techniques. Now, those techniques are based on two-step process. So what was there in the case of machine learning? You had given the suppose you are solving some problem. Suppose I'm giving you this image, and I'm asking you like what is the level of this image. So for you, like you can easily say like this is car, but we have to somehow let this thing to be understood by the computer. So we'll give this thing to the computer, or we can say this machine learning pipeline. And machine learning pipeline is having two guys. One is sitting here and one is sitting here. Now, this guy, the job of this guy is to extract the information or extract the crucial or important information from the input. So this guy will, this image is having a lot of information, and from this image, it will extract the useful information. Okay. And then those useful information would be given to the second layer or second guy who will do the classification. Now let us understand this thing with, I'll just give you one analogy, one example, a real life example. Let us see this feature extraction and this classification through one example. Suppose I want to take few students or few members for my research team. Okay. And suppose this is my class, like this EM Tech class is there. So a lot of students are there, a lot of people are there. Now my goal is to extract, my goal is to select few people from there for my research team. Now what will do? Now I'll go to each and every person. Suppose I'm going to person one, and then my job is to get some information from that person. So what I'll do? I'll just I'll try to get some information from that person. Now the question is, how many or how much information we have in in a person or in the selected person? How much information I can get from the particular person? That's the question. Now, if I'm talking about one person, he's having infinite amount of information because he's wearing some clothes, he's have his hair is like black color, his 10th marks is this, his 12th mark is this. He's having a lot of information, or in broad term I should say like he's having infinite amount of information. But are we interested in every information whatever we have with that person? No, because every information is not useful for my this research team. So whenever I'm going to select some person for my research team, I'll be asking only relevant questions which are helpful or which will be helpful for selecting that person for my research team. So since the job or the problem statement is selecting person for my research team, then I'll be asking the relevant question for the research. Okay, so what I'll ask, maybe I'll ask, what is your 10th marks? What is your 12th marks? Or maybe what is your percentage in BTech or like that? Okay, have you done some project or not? So these type of questions would be asked. Okay, and I'll be asking these questions from every person in this group, and then I'll be getting answer from every person. And then I have one guy who is going to take the decision. So whether I should select or I should not select. So the job is to classify between selection or not selection. So we have yes and no, two classes. So yes means I'm going to select that person based on the answer. No means I'm not going to select that person based on the answer. Okay, so let us try to correlate that thing with this machine learning example. So here the person is this input, and this input is given to the feature extractor. Now feature extractor is the guy who will ask the relevant question for solving this problem. So he knows like what type of question I should ask for the particular problem statement. And here, what is the problem statement? Problem statement is like whether it is car or not car. So this guy will ask the question, relevant question, and all those questions, all no, not question, all those answers, whatever he got from the every person, will be given to this part. And this is another guy. So maybe what I'll do, I'll just assign PhD student. Here, this is the PhD student. I'll give the PhD student to for asking the questions. And then here I am sitting. And I will be there for deciding whether I should select that person for my research team or not. So whether what is the class of this, so that will be decided by this guy. So we have two different guys here. Okay. Now let us change the problem statement. Suppose instead of selecting person for my research team, now I'm going to select the person for my cricket team. Now problem statement has been changed. So if I'm changing the problem statement, then what will happen? Can we go with the same set of questions what we have asked for the selection of person for the research team? Will that work? No, it will not work because selection for the research team is different problem statement. Now here, like if I ask like what is your 10th percentage or what is your 12% percentage, that will not work because that is not relevant for the player. You know that Sachin was like matric fail student, and still he got that achievement. So that 10th and 12th standard marks are not relevant for the selection in the cricket team. So that's what I'm saying. Like whenever problem statement is getting changed, this guy will also change the questions, and then answers, whatever answers we are getting from here, that will be given to the decision making step, or like it is also called classifier because it's like classifying these things into two classes or multiple classes. Okay. So in the machine learning, when I say machine learning was two guys. One is feature extractor and one is classifier. And whatever he's doing here, he will give the answer, he will give the features to this. And then finally it will give the classification. Now there was problem in this case. And that problem was that if suppose this feature or this guy is not very good, if this guy is not very good, this can give you wrong features or wrong information. Now, if you are getting wrong information and giving to this, your classifier may be affected. And once your classifier is affected, it means like you are getting wrong result or your performance is getting decreased. Now, how to improve it? Now, how to say to this guy that you should improve? There is no mechanism. There is no any feedback system here in the case of machine learning. So if feature extractor is making mistake, you cannot give the feedback to the feature extractor. And that was the problem in traditional machine learning. And then this deep learning came into the picture, and it says that I'll combine these two guys in a single box. So this is your deep learning. So everything is in the single box. So your feature extractor, your classifier, all the things have been combined in a one pipeline or one box. And now in this system, there is feedback. In this particular scenario, there is feedback system. So whenever it's giving car, it's giving this input, and then suppose your classifier is making wrong result. Okay. Now feedback will go back, and then it will say to this classifier, hey, you are making wrong. And then classifier will also try to, this guy will also try to get himself correct. And at the same time, it will also send the information, that feedback to the back, to the feature extractor. And what it will say, like, oh, feature extractor, you are making some mistake, you should correct. So your feature extractor will also correct. It will also make itself correct, and classifier also will make itself correct. So it's like feedback based system, and that's why this is highly popular. And everything is in a single box. So you no need to take care of feature extractor, classifier separately. Everything in a single box, and that will solve the problem. Okay. So let us go for next slide.
Sir,
I think that
I am having one question.
yeah, please ask.
Sir, first, just go to the previous slide.
Yeah, please.
Yes, sir. So whenever we are talking about the machine learning, so generally what we learn from the books, that it is saying you have to give some data set. From the data, it will extract the features, and from the feature, it will understand the pattern, and based upon that, it will give the output. So it is altogether a automation. So there shouldn't be any person being, means it is learning the pattern from
mm,
the data. So this is what
mm,
the uh,
mm,
means what we are seeing that has been given as a definition.
mm,
But sir, when you are saying that, so we are
mm.
putting one person who is extracting the feature
Yeah,
from
that
the
person
input
means
data.
you have, yeah, person means you have algorithm. So I'm just
Uh,
giving the analogy, but that person means there is algorithm there. So one separate algorithm is for feature extractor,
yeah.
feature extraction, and one separate algorithm is for classification. So these are like two different algorithms that we are using. So I've just
Hmm.
given the example, like I've just related with the real life example. So that's why I've said that this is one guy, this is another guy. But these are like algorithms.
Yeah. So okay, sir. Okay,
Okay,
sir.
so this is just overview lecture. So
Yes, sir.
that's why I'm just giving the top view of everything.
Yeah, the
Oh,
way you explained it, it was very interacting actually. Thank you, sir.
thank you, thank you. Okay, so okay, now deep learning came into the picture, but actually deep learning was already there. It's not like new technique. It was there even in 90s also, 1990s also, 80s also. But that time it was not quite popular. And the reason was this: computation and data. So these all the techniques, like some of the techniques were already there in 1990s also. And people also use those techniques for solving some of the problems. But these techniques were not highly popular because of this computation and data. Now, computation, whenever I'm saying deep learning, it means like deep. So you're going in a deep. That means you have a lot of layers. If I just say the technical word, then a lot of layers are there. Or maybe if I give the analogy, then a lot of guys are there which are involved there in between. And everyone will do something on the data. So that means you need a lot of computation. So you should be having high, very powerful computational power. You should be having very high computational power. Now this was not there in 90s, 80s or 1990s. That time we did not have GPU. Actually, GPU is required for deep learning, graphical processing unit. That is having a lot of cores. It means like you can process multiple process in parallel. Okay, so that was the issue at that time, and that's why this deep learning did not become popular in 90s. This was the one reason, and another reason was data. We did not have a good data set at that time. We generally had like this MNIST data set, and that was like very small data set. So due to data set also, it did not become popular. So these were the two hurdles at that time. So we did not have good computation and we did not have good data. Okay. Again, some of the researchers already done some work even at that time also, like Likund, like he was doing PhD at that time. He did PhD on image recognition and he has used basic CNN, like this deep learning network, for solving that image recognition problem. And he got like decent result. But again, only few works that you can see at that time. Now, when 2007, 2008 came, around that time, this computation power become like like at that time this you like this all the GPUs came into the picture. So computational power got increased, and at the same time, around 2009, one big data set, that is ImageNet, which came into the picture. So Fifili group, she's from Stanford University, this professor in Stanford University. So she got published that data set, ImageNet data set, and then everyone started to jump in this area. Computation become good, data also become good. Now people started to uh, like we can say implement new algorithms. They started to think about algorithms, and then deep learning, like that is the, we can say like that should be like starting point of the deep learning. Okay, so and everyone started to jump in that area. Okay, so again algorithms, a lot of different algorithms came into the picture, and again we'll go one by one. Okay, so let us start with very basic problem what we have in the computer vision. Now this is the basic problem. So in computer vision, again, if you study the computer vision, you will start with this particular problem. This is called image classification problem. So you have given this image, and your goal is to give the label of this image. Like, what is this? Okay. Now, for the human, if I ask this question to anybody, like from our this team, you can easily say like, this is cat. Okay. Now, how you are saying this thing? How you are interpreting this thing? Like your eyes is taking the this visual picture, and then your brain is interpreting, and then you are saying that this is cat. Now, how it is coming from your brain? Because your brain has been trained in that way. So from childhood, your brain have has been trained in that way, and now you are expert for these all type of problems. So for visual picture, humans are very very good. So if you show any type of visual image, you can easily interpret like this is something, this is something, this is something. Now this job is not easy for the computer, because you know that your computer is a different type of guy. He cannot understand this visual thing. Your computer says that I will only understand the numbers. I can only understand the binary values. Now, if you are giving this image, no, he will not give you response. It's similar to like whenever you want to talk with Chinese people. Now, Chinese people cannot understand English or maybe Hindi or maybe local language. Now, if you want to communicate with Chinese people, and if you're just saying in your language, they will just ignore you. Now, what you have to do? Now, you have two, you can go with two ways. Maybe one way would be either you learn the Chinese language. Now, that is very, very hectic thing. Or you just hire one translator who will convert your language into Chinese, and then Chinese will understand, and they will give the response. It's similar like our prime minister also, when he go somewhere, so he like generally translator, you can see like translator would be there, and when he speaks, then translator will to convert it into the corresponding language, and then similarly for the response also. So even in this case also, since this machine language is very very difficult, like if somebody says me like understand this binary number, because computer can only understand the binary, it will be very very difficult for us. So why not choose some easy point or easy type of uh, uh, thing which will make this process simple. So in the case of computers also, we have a compiler or translator. So whatever you are writing, it should be converted into, it will like that is the job of the translator, that convert into the machine language. Okay, so this visual thing cannot be given to that. Okay, so it will be converted into numerical values, and then that numerical values would be given to the machine or your uh, like computer. And now computer is having the algorithm which will give you the label of this. Now again, this is not easy task. Why? Because you are giving the numbers, because this is not now image. This is like a set of values that you are giving to the computer. And then you're saying, you're asking the computer to give the label of these all the values. Like what is the label of this matrix? It's a challenging problem for the computer. And that's why this image classification is not the easy problem. But nowadays people see this as an easy problem because we already have done a lot of work in this domain. But this is not easy problem because from these metrics you are going to give the label, or your machine or your computer is going to give you label, and that's challenging problem. So how people solve it? How this machine solve it? It actually, whenever you are solving, this is also called classification problem. So we could be having multiple classes like one cat, one dog, etc. So suppose you have two classes, cat and dog. Okay. And now you are saying that you're assigning this task to the computer to differentiate or to find the boundary which can differentiate between cat and dog. It means your machine should be trained, or your machine should learn. Okay, so like humans, computers should also get experience because we generally learn from the experience. So from the childhood, we learn from the experience only. So whatever we see around this or maybe surrounding that, we just observe those things and then we learn from that. The similar thing we should give to the computer, or like this machine learning or this image classification algorithm also, because it has to learn, and for that we have to provide the this experience. So that experience is the data. So experience, okay, so I forgot, like every whenever like I've just given the example, like I'm asking the question from in the class from everyone. Now each this class could be considered as a data for me, because I am going to solve the problem with the help of this group, and that's why this is the data. And every point or every person in that class would be considered as a sample, data sample. And I'll be asking the question, or in a technical way, like I'll be extracting the information from the sample, and then we'll be having the classifier who is going to learn, like what type of, how should I give the label so that it will be correct, so that wrong person will be not selected. Okay, so first you have to train. Your model should be learn. Okay, so this is the learning process. So when your model is learn, now this can differentiate between two classes. So it's like just binary class classification problem. So this is cat and this is dog. Now one classes, all the samples of one class are given this side, and all the samples of dog classes are given this side. Okay. So these are like one, every point is one image. In this case, like when we are solving the image classification problem. Now this is just like, if I just give the analogy, then this is just like India-Pakistan border. So we got the border. Now border can differentiate whether this person is Pakistani or whether this person is Indian. So your border should be somewhere which can easily differentiate between Indian people and Pakistani people. So we want this border. We want this line or this curve which can differentiate between two classes. And this is, by looking this, you can say like this is linear. So this is called linear classifier. So this was like, this will be like our first topic. So when we'll start, then we'll start with the like not first topic, but this will come like after our first topic. And again, we'll put a lot of time for this topic. Okay. So here, like this is not easy job, because sometimes some of the Pakistani people can go to the India, and it generally happens. And vice versa is also possible. So we have to somehow find the boundary which can fully separate, or at least it should work for most of the time. It should not be happen that every time it is making mistake for putting people different side. So maybe many times it's just putting the Indian people to the Pakistani, or to like Pakistan side, or maybe Pakistani people to the India side. So that should not be happen. Okay. So that is the job of this boundary. So our goal is to learn this boundary, or model. The job of the model is to learn this boundary, which can differentiate between different classes. Okay, so linear classifier is the first step in the case of neural network or in the case of this computer vision. Now, in this world, most of the problems are not linear, or most of the problems are very, very complex. So whenever you have easy problem, you can apply linear classifier, it will solve the problem. But the reality is that we have, most of the time we have problem which is very, very complex. And whenever you have very, very complex problem, your simple linear classifier will not solve the problem. And for that, neural network came into the picture. And this is the starting point of deep learning. So neural network is again a set of neurons, a set of layers which will try to solve the particular problem. And how it works? Actually, if you just see here, this these are the nodes, and this is called input. So you are providing the input here, and then you are getting the output. Output could be like decision making, like whether this is cat or dog. So we can, one node can give you two values. Either cat means 0, one means dog, one means dog. So one at the end, one node will give you, one node is sufficient for giving two classes. Or maybe for my research team, then yes means one class, no means another class. So if I'm selecting that person, then that will give you yes, otherwise no. Okay. Now if you just carefully see here at this point, we have values this. Now these are called input neurons also. Actually, this deep learning has been inspired from the human's brain. And in our brain also we have neurons, axons, and like that. And just we tried to mimic the human brains, but still it's not that easy. So still it is different than our brain, but somehow we have given uh, or somehow different things have been inherited from our brain terminology. Okay, so this is input, and then this these are like mid layers, and again we'll put a lot of time for this also, this neural network also. Now if you just carefully see here, now what is this? These are like values. It could be one value, it could be another value, it could be another value, and these are the values coming from the input. But when I started this, what I said that this image will be converted into 2D matrix. Now this is 2D matrix, and here you are just seeing that this is 1D, because this is vector only. You just combine all the values, it will make the vector. Now how can we give this matrix to this? Because this network is not accepting the matrix, it is accepting the vector only, like 1D thing, 1D vector. But here we have 2D vector or matrix. So whenever you want to use neural network, what you have to do, you have to convert this matrix into vector first. So this image will be open. Again, we'll see these all the things in a great detail. So this matrix will be open, and you will make the vector from this, and then you will assign this vector to this, and then this will be processed, and find at the end it will solve the particular problem. So this is like the starting point of the neural network, this deep learning. Now let's go for some of the problem. So we have seen this problem till now. This is called classification problem. So classification problem is very, very simple. Give the image to the model, and it will go in a matrix form, and then your model will say, or your machine learning or deep learning, whatever you are using, that will say like this is cat. Now this is not the only problem that exists in this world. We have a lot of problems. Now let's see some other problems. Now this is semantic segmentation. Now this is one step ahead of this. So in the semantic segmentation, you have to, like, model or machine learning or deep learning has to classify every object in the image. Now in this image, if I just carefully see, these are the grasses. Here we have grass. Here we have cat. Here we have all the trees, and then we have sky. So in Broadway we have four different classes. Now your model should give, or it should cluster all those four classes. So it's saying, like, it's giving green color to the grass, then yellow color for the cat, then this color, red color for the tree, and then maybe orange color for the tree, and then this blue color for the sky. Now this is even more challenging problem compared to the first. Why? Because here you are doing classification at each value here. Because each value in the 2D matrix, because your image is getting converted into 2D matrix, and then you are classifying every value of 2D matrix into some class. So every value, because it's like coloring the object. So it's like even more challenging than the first one. Because in the first one, just give one label for whole image. But here, and this is also called pixel. You might have heard this name before. So each pixel is getting classified in one of the classes. Okay, so this problem is called semantic segmentation. Because you are segmenting, you're just based on the semantic information, you are clustering different objects. Now just go for another problem, object detection. This is also very, very useful problem, very useful application. Object detection, whenever you do this object detection, you might have done this thing in your, maybe in your work also. So the job of this object detection technique, again, this is the part of whatever we are studying here, everything is part of deep learning only. So we are just, they have used some deep learning techniques for solving these all the problems. Now in the case of object detection, what it's doing, the job is to localize every object, the image, or interested objects of the image, and also give the class of that. So you can see here, this dog, this dog is given the box here. And this box is saying that this is the location of this box. So we have X, Y, and height and width. And at the same time, it's also saying that the red color belongs to class dog. Similarly for this part also, the small dog, and then for this part also, that is cat. So what is doing? It's detecting the object, or it's localizing the object, and at the same time, it's also giving the class of that object. So detection means it has to give the location of the image, where the location of the object, where the object is, and what is the class of the object. So those two things we are getting from this object detection. Now there is use of this particular techniques in real life application. Let us take one example. You might have heard this self-driving car. Self-driving car is like driverless car. So it's running on the road without driver. Now how it is happening? Now if you just carefully see the self-driving car is having a lot of sensors, or maybe we can say a lot of cameras. And it is taking image from the surrounding. So whatever your car sees on the road, or maybe surrounding, it's just fetching all those things, or it's just capturing all those things, and then it is having some algorithm which is giving the location where every object is, and at the same time it's also giving the class. And for that, in some way they are using object detection, because object detection is the technique which can give you location along with class. And this is very, very required thing, because whenever car is running on the road. Suppose some pedestrian or some people come on the road. Now car has to stop. But how the car will decide that I have to stop? That would be based on this object detection. So it will take the image, and then it is taking image every time, and it is also taking decision every time. So whenever it's taking the images, then it will process it. It will apply the object detection algorithm, and then it will find like what is the position of the object, and what is the inside the like what is the class of the object, and based on those two information, it will uh, place the brake. Okay. So and accordingly, like the car will be stopped. So every time it has to decide. Suppose stones are there, or maybe small stones are there, or maybe small pages are there on the road. In that case, car no need to stop because that is not dangerous. Only when humans or some larger things are there on the road, then only car has to stop, or maybe some other vehicles are there on the road. Then in that case, only the car has to stop. Otherwise, some small things are there, then car no need to stop in that case.
And sir, in this semantic segmentation, you have marked it, you have classified the entire image into 4 groups there. And can we the cat itself? If I classify the cat itself into further, can we do it further classification there?
Yeah, that can be also done. Like you can
Yeah.
classify tail, maybe moth, then maybe
Yeah.
different parts of the cat. That is also possible. That could be like one another type of problem.
Okay, sir. And how about classification of image in the night, sir? How do we do it? Is it possible? How do we do it in the night?
Yeah, these like nowadays people are also solving those type of problems. So again, this all the things are based on the experience only. So like what you are showing to the model. So if you are showing those type of images to the model, then your model will learn. Like if we are getting some like dark image or like night image, then in that case also I should detect it, or I should classify it. So again, this is whatever you are going to do, you need to provide that type of data also. And that's why this
Okay, sir.
ImageNet when came, ImageNet is having all those variations. We'll discuss these all the things in a great detail, maybe next
Sure,
lecture.
sir. Sure.
So,
Sir, what is the difference between semantic segmentation and instance segmentation? Can you
so semantic means like we are focusing on like the full image. So like it's segmenting semantic, like just in the full image we could be having different type of things. When I'm saying instance, then I'm focusing on the object part. So like my area of interest is like only object, only these like cats and dogs. I'm not focusing on the background part. So this is just I'll come to this. I'll come to this like after it's just like extension of the object detection. Instance segmentation is like extension of the object detection where we are not taking care of full image. We are not taking care of background things. But in the case of semantic segmentation, we are taking care of everything inside the image.
Okay, thank you, sir.
So let's come to the instance segmentation. Instance segmentation is just extension of the object detection. So in the object detection, like here if you see, we are getting the rough estimation of the location of every object. Okay, so this is not the exact location. It's like rough estimation. But now if you see in the instance segmentation, its model is giving you the exact location of every object. Now, many times we also need this thing. For the driverless car, for the object detection in the driverless car, maybe you will be happy with this object detection because we no need to go for the exact. We are happy with the approximate location or rough estimation of the location. So we are fine with that. But in some applications, we need exact location. Let me just give you one example. Suppose surgeon or like doctor is doing the surgery of the brain, and inside the brain, if suppose there is tumor, or maybe it is sitting on the white matter part, or maybe on the this gray matter part of the brain. Now In that case, if doctor is using this object detection, now object detection will give it will not give the exact location. So in that case, maybe your tumor is this and it's giving this location. Now, if the doctor use this thing and it just insert the needle and it just take it out from the brain, what will happen? Your tumor will came out, it will came out outside, but at the same time, these are the good tissue which will also came out. And you know that your brain is controlling this whole body. So if you just disturb some of the tissues of the brain, the control of some of the parts of the body will go. So this is very, very crucial. Like in the brain, if you are going to segment the tumor or different parts of the brain, there should be uh, exact approximation or exact position. Otherwise, we may make some mistake which can maybe create the issue for the patient. Like, let's give you one example. When like one guy, he was like he's alive. He's like great guitarist in USA. So like maybe few years back, he got this brain tumor, and then he just uh, contacted to doctor, consulted to doctor, and then doctor said that we can do the surgery and we can take it out from your brain, but we are not sure because whenever we are going to insert some needle in the brain, in every case it will disturb some of the tissue, and if it is disturbing some of the tissue, that means some controls will go. That means some of the parts of your body will be paralyzed, and that is guarantee. Now what he said that this fine, if some part got paralyzed, that's fine, but I should not uh, forget this art, because I can only survive with this art, that is my this guitar. So I should not forget this playing the guitar. Then what doctor did, when they were doing this surgery, at that time this guy was just playing the guitar and they were just observing the patient, and this whole surgery they just observe the patients. So a patient should not uh, forget this thing. Okay, so he was doing they were doing this surgery in such a way so that patient should not forget this thing, and successfully, like this surgery happened successfully, and finally that person is still alive and he is very good in guitar still. So that's why I'm saying, like, so whenever you are going for the brain surgery or this tumor like surgery, like that time you have to, like, your doctor will ask like the priority, like you, because everybody knows that whenever you your tumor is in the white matter part, reaching to white matter part will disturb a lot of tissues. So control will go, but which part you want to be survived after surgery. So that's why whenever you are talking to the doctor, you have to give the priority. Like, I want this thing after my surgery, and then they will take care of that. So whenever they will be doing surgery, they will just take care of those parts so that those parts would not be paralyzed or would not be missed after, or your control would not miss the control of those parts after surgery. So this is very, very crucial application, and nowadays even uh, uh, we have robot also. So robot can also do surgery. So robot is being trained in that way, like it can do the surgery. And in USA, in several hospitals, they use robot not for a major surgery, but generally for the minor surgery they use. And then doctor will also there for. So it means like doctor is required, but now with the help of the doctor, your robot is doing the surgery. Even in the China, we have one uh, hospital where there is no any person involved. So mostly the robots are there. And whenever you are going on the counter, that lady will be also robot. Talk to her, then even all the doctors will be also robots. So it's like that type of setup is already there in the China. So you can see like where this world is going on. Okay, so let's see some other type of problems. So we have seen like these all the image type of problems. Now let's go for uh, beyond image. So we have video also, and nowadays everyone is using video. So you might have used some this short video, or maybe some this what we say on the reels. So everyone is using video. So now we are interested in the video. So instead of image, like image is also the interested modality, but nowadays like we are shifting towards the video. So even on the internet also, 80% this congestion is due to video only. And now so you can like just appreciate it, like how in what quantity we are using the video. So that's why now if we are using video, we want to apply this deep learning on video also. Now, what are the problems that we can solve on the video? So this is one problem in video classification. So video classification is just like it's like an extension of the image classification. So in the case of video classification, now if I ask you what is video, so video is just like frames. We have a sequence of frames or sequence of images. So we have given a sequence of images, and you have to decide like what is there inside that video. Okay. So suppose this is the problem. So we have given the sequence of images. So this is just I'm showing one image, but we have like a lot of images in sequence. And then this your model, your deep learning model has to give the class of this or level of this. So suppose in this case, this label would be like running because the person is running, or maybe person is jumping, or maybe we could be having different type of classes. Okay. So again, this is not easy task, because in the previous job, like we were just giving the image, one 2D matrix. Now here we are giving a sequence of 2D matrix to the model, and then your model will decide like what is there inside that. Okay, so this is like again, and already these problems have been solved up to certain level, and still people like research are still going on, but these are like already solved problems. Then another type of problem would be multi-model video understanding. Now this is again one step ahead of this. Now here you can see like this person is playing something. Now that is like one type of thing. So person is playing something, so we'll be having a lot of images, and you can see that activity, like person is doing something or is playing guitar or maybe something else. Now that is one type of modality, that is like sequence of images, but at the same time the sound is also coming from that. So sound is also there, and images are also there, sequence of images are also there. That's why this is called multi-model, because we have different type of data. One is video data, one is audio data, and based on these two type of information, model has to decide, or model has to understand what is happening here. So this is called multi-model video understanding. So this is again one type of problems, and already a lot of works are going on in this area. Then another thing is visualization and understanding. So this is also again very good area. Like initially when this deep learning came, so people just say like this is black box, because you cannot understand like what is happening inside that. But later, like again, once any innovation happened, then at the starting people don't know like what is there, how it is happening, but later everyone started to give analogy, interpretation. So this area is only this area talks about that, like how what is happening in every layer, what our model or what our deep learning is trying to learn from the image while training. So those are all the things will be done here. Actually, if you just see in reality, whatever we are doing in the deep learning, everything is mathematics. We are just solving some problem and we are using some function, that's all. But the problem is that that function, the understanding of that function is beyond our understanding. And that's why we say this thing as a black box. So if you do not understand, we generally say as a black box. But nowadays, again, research is going on in this area, and this is also very interested area, or it's like theoretical area where mostly from mathematical background or maybe from a mixed background, the people jump into this area to get this understanding of the model. Okay. Now, apart from this, like I have started with this first layer. Then I shifted to the problem statements. Now, again, just come to the layer. Just come to the models. Okay. So, first model that I've shown you, that was the neural network. That was the initial deep learning network. Then there was a lot of issues in the case of neural network, the basic neural network that we have seen in the in previous slides. So they're like, what was the problem? The problem was that you're fully this neural network was doing good. This whenever I shown that this neural network, this was the where that neural network is there. Yeah, this was the neural network. So here actually what was happening? Like your input was given to this, and now if you just see, this is the output of this layer. Now every output is connected to every, like each output is connected to every input. Let's give you the analogy. This is just like when you are going to the moon and you are looking the earth from the moon, and then you have been asked that you take some decision about the earth. So from the moon, what you are seeing on the earth, you are just seeing the top view of the earth, because you cannot see the detailed information of the earth. That's not possible from the moon. So you'll just give the decision based on the top view, based on the some this we can say the global view, or maybe some what we can say it's just the overview of that, because it's not giving the detailed information. And that was the problem in the case of neural network, because it was looking the things from the very top. Now, later people realized that we should be having some mechanism which will see the things from the different uh, location. And for that, CNN came into the picture. This is called convolutional neural network. And what it said that if I want to take decision about the earth, what I will do first, I will go close to the earth. Okay, and then I'll have a camera, and then I'll take the image of the earth. Then again I'll go some far from that, far from that, far from that. At the end, I'll be reaching to the moon only. But reaching to the moon, I already have seen the earth from different resolution or from different distance. So it means like I have the picture of earth from different view or from different location. So it's not only overview. It's like we have also detailed view. We have also some detailed view. We have also global view. We have also overview. So all type of information is there. And now, due to those all type of information, your model will learn, or your decision making will do the proper decision. So this CNN is just like that idea only. So it takes, so it's also called hierarchical way of training. So start from the closing distance and go far, go far, go far, go far. At the end, you just reach to the global things. So this CNN generally used for the image type of stuff. Like, well, we have some special information like image, video, like that, and do this does very well in practical scenario compared to this neural network, basic neural network. Now let's go towards some other type of problem statements. So initially, like we had, like I have just told you that we have images, videos, and then we solve some problems. Now that is one type of areas where we work, but we have different type of domains also, which is very different than the images and video. And that domain is called NLP, Natural Language Processing. And here we generally deal with the text. So we have text, and you can see like every day we see a lot of text, even in the book or maybe at different places. Now, how to interpret something from the text? And that is the job of the NLP, natural language process. So we have to understand the texts. So we have different type of problems which we solve in the NLP. Like, just I will just give you one example, like sentiment analysis. So sentiment means like given the text, and you have to decide like what is the sentiment inside that text. So whether this is positive sentence or whether it is negative sentence or it is neutral. Okay. Now for those type of input or for those type of problem statement, this CNN or this fully connected will not work in a proper manner because they have not been developed for solving these type of problems like NLP problems. So for solving these type of problems, again, new type of these models came into the picture, and the initial model was recurrent neural network. So again, we'll deep dive into this RNN, and this is like mainly for the text or sequential information, sequential input. So if you have in the problem statement, if you have sequential information or you have text type of information, we generally go with this RNN. So RNN, like it was quite popular around 2000, like before 2017, and people used to use this RNN or variant of the RNN like LSTM for solving different type of NLP problem. But when 2017 came, at that time, transformer came into the picture. So RNN and LSTM was good, but the problem was that these approaches were very slow because they were not using this GPU power in a proper manner. So that was the issue. And for even there were some other issues also, but solving the issues of this RNN and LSTM, this transformer came. And when around 2017, and then everyone started to use transformer. And transformation can be seen as a benchmark model for this NLP task. And let me just tell you, this transformer is not limited to the NLP only nowadays. Nowadays, people use this transformer for solving all type of problems like computer vision problem, like NLP problem, medical problem, agriculture problems. All type of problems can be solved using transformer. So you can see the advantage, you can see the popularity of this transformer. Okay, so we just talked about all the recognition type of problem. Now let's see some other type of problem uh, which have been solved by deep learning model. And this is like one problem where this is called generative modeling. So here your model is generating something. It's like also called generative AI. So you can see like you are providing this image. This is the input image, the real image that you are providing to the model, and your model is giving this cartoon image. Oh, this can be done in a second. Just give to your model. Even already a lot of tools are there on the internet. You just give this, it will give you this type of things. And it's very, very good cartoon image that you are getting from. Now you can, if you want to get same cartoon image from the cartoonist, that person may take 1 day or 2 days to complete it, or maybe hours to complete it. Now the same thing you are getting from the model in a second. In this way, this type of model is taking the job of cartoonist. So you can, like, this is the this is the dark side of this deep learning models. But again, what deep learning says that if you want to be survive, you should be updated. So otherwise, you will not get job. So you have to learn this AI. You have to go with this AI. You have to go with this deep learning. Otherwise, you will be not able to survive. Okay. So whenever new technology comes, you have to follow that. You should be you should be updated. Otherwise, you will be in trouble. Okay. Now another type of genetic task is this. So here you can see that this is again interesting problem. So here what we are doing, we are just giving this text. We are just giving text to the model and just giving text to the model. This teddy bears working on new AI research underwater with 1980 technology. And already deep learning model is there, Delhi E2, which is again based on the transformer or some different type of architecture, and is already available on the internet. You can just find it out, and this tool is available. You can just give this thing to that tool, and you'll get this. Now this model is giving you this image. This is the generated image from the text. So you're saying that teddy bears working on the new AI research underwater with 1980 technology, and you can see those images. Teddy bears are there, AI research, doing some type of research, and the technology looking like 1980 technology. Now you can say like how smart your model is. It's just like when I'm going to the class and when I'm asking, when I'm just giving, everyone has to draw the image of car or maybe cat, and everyone started to just draw it. A similar thing can be done by the computer also. Similar thing can be done by the deep learning also. Just give it and get the image in a very fast manner. Then this is again few different examples. Teddy bear working on a new AI research on the moon in 1980s. You can see that image. Rabbits attending a college seminar on human anatomy. You can see like all the rabbits are there. Human anatomy is there, and one guy who is teaching there. A wise cat. So these are like hypothetical images, but still your model is giving you that image. A wise cat meditating in the Himalayas, searching for the enlightenment. And you can see the exact picture here. So these all the things can be generated by the deep learning tools. This is again one extension of Delhi E2. So this is called Delhi E3. So in Delhi E2, we were giving just one sentence. Now here you can give the full paragraph and it can generate the cartoon type of, like in childhood, we generally uh, read, used to read some cartoon book. No? So the similar book can be generated by this Delhi A3. Then GPT-4. Uh, Chat GPT, you might, I think everyone must have used this Chat GPT. Now Chat GPT is based on the GPT, and GPT is one variant of the transformer. Now in the Chat GPT, whenever you want to ask something from the Chat GPT, what do? You just put the prompt, put the text, and then you get the response from the Chat GPT. Now Chat GPT, the initial Chat GPT did not allow you to put image. But GPT-4, because that was based on the GPT 3.5. Now GPT-4, which is again the variant of the transformer, it came up with the idea that I can also take the image from the input. So now you can give text and image both. So you can ask, what is unusual about this image. You're providing image also and asking the question. You are getting the answer. The unusual thing about this image is that a man is ironing clothes on the ironing board attached to this. So you can give the image and you can ask the question. This thing can be also done using the model. Then another type of problem is segment anything model. It's like one type of innovation, one type of model which is like it's developed by this Meta. And what's doing like when I was doing research like around 2017 or 18, that time like we were solving like this segmentation problem was every time like just like we have seen in a previous slides. So giving the image, we have to segment it where that object is, location. Like that. Now, when I was working at that time, we used to develop different algorithms for solving different type of segmentation problem. For example, if you want to solve segmentation problem for the medical image, you have to, or maybe some selected type of medical image, then you have to develop one separate algorithm for that or separate model for that. Similarly, if you want to switch from that problem to some other problem, you have to develop another model. N number of models for solving n number of segmentation problem. But this segment anything model came with the idea that I can segment every type of image using single model. So this you can see like where this deep learning is going or how fast it is evolving. So nowadays, like you can use this segmentation to this SAM model, and you can the same model can be used for all type of images. Like you can give medical images, some natural images, any type of images you can give, and it will give you some answer. Yeah, like sometimes it will also fail, but again you can continue for making even better in that case. So fine tuning is always there. Okay, so your model is there. Model means like model will make mistake also, but you can correct the model for doing good next time on same type of images where that model failed. Okay, this is again video generation work where people you can use to generate the video also from the image, or you can also uh, use model to edit the video which was being done previously manually. Nowadays you can do in an automatic manner. This is a video. It's like just first frame is coming, but it's video. Even beyond 2D nowadays, people also you work on 3D vision. 3D computer vision is again one area, because in 2D image, whatever you have shown to you, those images are not having depth information. So you cannot say like how far one object is from other object. But now we have 3D vision also, where we can say like how far one object is from another object. So we can also, it is also giving you the depth information. So for that type of area, again, we have a lot of techniques, and people use a lot of deep learning techniques to solve those type of problems. Now, can I take 5 more minutes, or do you have some killer? Do you have?
No issue, sir. No issue. Sir, one point
Oh, uh,
during this discussion, sir, diffusion is one model. It is it a model or it is a sub part of any of the?
uh, d- actually, those are like techniques. Diffusion is like
Mhm.
generally people also say models, but diffusion can be seen as a one type of techniques. How to train the model for the generative AI, or for the solving of particular problem. But
So,
vaguely people also use term as a model for that.
so that means we cannot say it is just like RNN or CNN. We cannot say like that, right? Or we can say that it is a diffusion model. I'm a little bit confused.
No, for example, GAN, generative adversarial model. So
Uh-huh.
generative adversarial network. So GAN is based on the autoencoder, based on the CNN, based on the RNN. But
Yes.
the idea they are using like for the generation task, that is the unique there in the case of GAN. The similar thing is there in the diffusion model also. So diffusion model has used the base architecture from the previous thing only, but it has given the idea by which it will give you the better model compared to the previous all the models.
Okay.
So at the end, you are getting the model. So you can also say this is diffusion based model.
Yeah, yeah, yeah.
Okay, so now I'll not take much time, but just to give you the godfather of this deep learning. So these three guys who you can see here, they are like godfather of this deep learning, and they have given this a lot of techniques related to deep learning, like Geoffrey Hinton, Bengio, Lee Kuhn, and Lee Kuhn, like he was doing PhD around 1990, and that time he did use this image. He did solve image recognition problem using CNN, the basic CNN. Now they got Turing Award in 2018, and Turing Award, like we can say, Nobel Prize of Computer Science, and for this contribution. Now, surprisingly, uh, this Geoffrey Hinton from this group, he got Nobel Prize in physics uh, in 2024. So these two guys got a Nobel Prize in physics, and he was like from that physics background. And this Hinton did got because a lot of unsolved problem in the physics have been solved using deep learning techniques. And since this guy has given a lot of contribution in deep learning, and those techniques have been used in the physics for solving a lot of unsolved problems. So due to that, he got also Nobel Prize. Okay, so you can see like how this area is evolving. So in physics also people are getting Nobel Prize from the AI. Even the same year in the chemistry, three guys got the Nobel Prize, and two of them from the AI background. And why they got? Because they have given AI-based techniques for solving unsolved problems in the chemistry. And those two guys are still working in a company, maybe in some Google or maybe some reputed company. They are working there. Okay, so this was the story. Now let's go to the last slide. This is very interesting. So I just put this slide here so that you can also see some other aspect of this deep learning. It's not coming. It should not. So what people have done, they have taken the scan of the different users, and some of were like users who are not using ChatGPT, and some of were like users who are using the ChatGPT, and they have just taken the scan of MRI scan of every user, every person, and then they did some average study on the brain, and this is the visualization of average study. Now you can see these are the guys who are using ChatGPT, and these are the guys who are not using ChatGPT. So you can see like this brain. So if the guys who are using the ChatGPT, these neurons are activated. It means their brain are working in a proper manner. And the guys who are just using ChatGPT blindly, you can see brains are not, only few parts or most of the parts are not working. So this is like dark side of it. So what I'm saying, like whenever you are going to use ChatGPT, you use it, but don't use blindly. Otherwise, you'll be becoming this. You will be lying in this side because it means like you are getting dull. Your machine is getting smart, and at the same time you are getting dull. So you should not make yourself dull. Okay. So whenever you are going to use ChatGPT or any type of tool, you should take the things from that. You can use it, but then you also analyze it, and then you also think it, and then you can also suggest something to the chat gpt. Don't take anything blindly. So that's the point that I wanted to put here. So with that, I'll stop here. And this some of the things I've taken from, like, I just acknowledgement part I put here. So CS231, that is again, uh, I'll be taking all multiple slides from there, even some slides from the internet also. Then I used or YouTube video also for understanding different things. So I've just put that acknowledgement part. Okay, thank you.
One
Uh,
more question, sir.
So if
Sir, one question.
do you have class or other class or
We have
no,
class at
no, sir.
11:30.
Okay, 11:30. Then you could ask.
So one question, sir. This ChatGPT. So if we use the ChatGPT for any
Hmm.
kind of users, does
Hmm.
ChatGPT also learn from our questions or data that we
Yes.
feed into that? It
Yes.
learns.
Yeah,
Okay.
yeah. Because it is
Okay.
having that feedback. So it can also learn while testing. So it's like that RL based techniques are being used there,
Okay.
reinforcement learning. So it learns. Yes.
And one more thing, sir. Is there any way where we can use where we can directly link to the ChatGPT by external application? Like, for example, if some questionnaires are there, if customers ask me some questionnaires, can I feed
Hmm.
those direct questionnaires to ChatGPT and get a description for that particular question from ChatGPT?
Yeah, that can be done. But the thing is, like, whenever you are getting response from the chat GPT, you should not fully believe on that. Okay, you should not be
Mhm,
blindly believe. You should not be blindly believe on
mhm.
that. Okay, so you should also
Okay.
use your mind. So get the answer from the that chat GPT, and then you just interpret it. Like, you just do the analysis of that. Okay. And again, if your chat GPT is giving you wrong things sometimes, then you can also give some prompt to the chat GPT, like, you are making wrong, you should correct itself. And then your chat GPT will refine itself. Okay. So next time it will give you the maybe the relevant or maybe the right answer compared to the previous.
Okay. Okay. Okay, sir. Okay. Okay.